Hello everyone, welcome to my class. Today we are going to discuss about measurement of time and simple pendulum. Okay, so let us start the class. Students, now we are going to discuss about measurement of time. You might have seen a pendulum clock in offices, at restaurants or at different places which we generally use to note the time. Pendulum clock is based on the principle of periodic oscillation. So now we are going to discuss about the simple pendulum and its working principles. Okay, students, let us now discuss about simple pendulum. What is a simple pendulum? Simple pendulum is a heavy point mass which is called the bob, and it is attached to a rigid support with the help of a strong and inextensible string. Okay, so now we are going to discuss about the terminologies related to simple pendulum. Okay, so in this case the bob is at a place which is O, and this is called the mean position. O is the mean position. That means it is the initial position of the bob when it is not in motion. Okay, and A and B are called the extremes. The bob which is at the mean position initially, if we bring it to either of the extremes, let it be A or B, and leave it, what happens? The bob comes to an alternative motion and it starts moving in either side of the mean position. So this is how the simple pendulum oscillates. The pendulum that we see in a pendulum clock is not a simple pendulum but a compound pendulum which has the property to oscillate about the horizontal axis that passes through its body. So now we are going to discuss the terms related to simple pendulum. Okay, students, the first term related to simple pendulum that we are going to discuss is oscillation. What is oscillation? A complete to and fro motion of the bob is called one oscillation. Okay, so let us try to understand it by looking into this diagram. As you can see, the bob is at its mean position O. If we push to either right or left, it will go certain distance, isn't it? So let that distance be A. So what happens now when we push the bob O and it goes to A? Then it moves through the mean position and goes to B and comes back to the mean position again. So then it completes one oscillation. That means O to A, then A to B, then back B to O. So from O to O, one oscillation. Fine. So from mean to mean, one oscillation. Same way, one oscillation can be the oscillation of bob from A to B, then back to A. That means if we bring the bob to either of the extreme positions, let it be A or B, then we leave it from that position. Suppose in this case I bring the bob to A and leave from here. So what happens now? The bob goes through the mean to B and again comes back to A through the mean. So A to B and back to A is also one oscillation. A to B, then back to A. A to A. Okay. One oscillation. And it is same from B as well. B to A and back to B. So B to B, one oscillation. Okay, hope you understand. Students, let us now discuss about time period and frequency of a simple pendulum. Okay, time period is the time taken by the simple pendulum to complete one oscillation and it is denoted by T. And what is frequency? Frequency is the number of oscillation completed by the simple pendulum in 1 second. So this is nothing but oscillations per second. Okay, and it is denoted by F or N and the units are hertz and second to the power minus 1 or per second. So oscillations per second or the unit of frequency, that is hertz. Okay, so let us now discuss about the relationship between time period and frequency. Okay, students, if T is the time period. That means in T seconds, the pendulum completes one oscillation. So in 1 second, it would complete 1 by T oscillations. So 1 by T oscillations in 1 second. That means it is the frequency of oscillation. So that means F is equal to 1 by T. Or we can write T is equal to 1 by F. So this is the relationship between the time period and frequency of simple pendulum. Okay? Students, let us now discuss about amplitude and effective length of a pendulum. What is amplitude? Amplitude is the maximum displacement of the bob on either side of the mean position. That means in this case, amplitude would be OA and that is also equal to OB. So OA or OB, it is the amplitude of the simple pendulum. Okay. What about effective length of a pendulum? Effective length is the distance of the point of oscillation. What is point of oscillation? Actually center of gravity. Center of gravity of the bob. Okay. So distance of the point of oscillation from the point of suspension is called the effective length of a pendulum. That means in this case OS that is equal to AS that is equal to BS. They are effective length of the pendulum over here. Okay. And it is denoted by L. Okay. Students, let us now discuss about the measurement of time period of a simple pendulum. For this, what can we do? We can go for an experiment. We need to fix a time T and we can go for 20 oscillation. Okay. So what would be the time period? Time period would be T by 20 and we need to do it for different lengths of the pendulum. As you can see in the table and you can observe that the length of the string in the first case is 25 centimeter and that of sixth case is 100 centimeter. So it has become 4 times. And what happens with the time period? The time period is 1 second in the first case but it is 2 seconds in the sixth case. From this we can come to the conclusion that time period is directly proportional to the square root of length, or we can write it that time square is directly proportional to length. Okay, and from this we can also come to the conclusion that L by T square is always a constant. Okay, and by using this relationship we can choose different types of pendulum as per our requirement. Okay, students, let us now see the graphical representation of the relationship between time period square and length of the pendulum. As you can see over here, the time square is represented on y-axis and length of the pendulum is represented on the x-axis. And you can clearly observe that the result of the graph gives us a straight line that is slanting towards the L-axis or the x-axis. That means it shows the time period square is directly proportional to the length of the pendulum. Okay. So what about the slope of this graph? As you can clearly see, I have taken 2 points P and Q on this straight line and there is another point R over here. So the slope of this graph is nothing but PR by QR. This is the slope. Fine. So what is the value of PR then? See, PR coincides with AB. So what is AB? It is T1 square minus T2 square. So T1 square minus T2 square. It is your PR. What is QR? So what about QR? QR is equal to CD. So it is nothing but L1 minus L2. So divided by L1 minus L2. So when we calculate the slope, it gives us a constant value that is equal to 4 pi square divided by g, where g is nothing but the acceleration due to gravity. Okay, so from this equation we can get the value of acceleration due to gravity. So if slope is equal to 4 pi square by g. So what is acceleration due to gravity? That is 4 pi square divided by slope, or we can write that acceleration due to gravity is equal to 4 pi square divided by slope of time square to length of pendulum graph. So if we know the value of the slope of time square to length graph and we know the value of 4 pi square, we can find the value of acceleration due to gravity. Okay? Hope you understand. Students, let us now discuss about the factors affecting the time period of a simple pendulum. Okay? As we have already discussed, the time period of oscillation is directly proportional to the square root of its effective length. So, time period is directly proportional to the square root of its effective length, or that implies t square is directly proportional to length. We have already discussed about this. Students, we have never observed the oscillation of a pendulum in a pendulum clock. Students, as we know that the bob of the pendulum, it is made up of metal like brass and steel, and same way the string that is attached to the bob is also metallic. So what happens in summer season when the temperature increases, the metals they gain more heat energy. So the effective length of the string increases because of expansion. So what happens in that case, the pendulum moves slowly or it oscillates slowly. Its speed decreases. So what we understand from this, that because of the increase in the effective length of the string, the time period of the pendulum increases. Same way in the winter season when the string contracts because of the fall in temperature, the bob it tends to oscillate faster. That means the time period of the pendulum decreases. So in decrease in effective length of the string, the oscillation or the time period of the oscillation decreases. Similarly, when we stand on a swing, the swing tends to move faster. Why? Because when we stand, the center of gravity of our body rises, thereby decreasing the effective length of the swing, and it tends to decrease the time period. As the time period decreases, the swing tends to move faster. Okay, hope you understand. Students, the next factor that affects the time period of a simple pendulum is acceleration due to gravity. As we have already discussed that the time period of oscillation is inversely proportional to the square root of acceleration due to gravity. That means T is inversely proportional to square root of G. So students, from this relation we can come to a conclusion that if the acceleration due to gravity decreases, time period tend to increase. That is why when we take a pendulum clock to a greater height, say onto a mountain, it tends to move slower. Why does the speed of the oscillation of the pendulum clock decreases at the height? Because the gravity that works on the pendulum clock decreases at a height, thereby increasing the time period of oscillation. Okay? Students, the time period of oscillation does not depend on the mass of material of the body suspended, that is the bob. That means if we take two simple pendulums having same length but two bobs having different mass or different material, then the time period would not change. Okay? Students, the time period of oscillation does not depend on the extent of swing on either side. What is that? That is our amplitude. Okay, but provided the swing is not too large. Okay, you need to keep it in mind. Okay, students, the time period of a simple pendulum is expressed with the relation that is T is equal to 2 pi square root of length upon acceleration due to gravity. That means we can write it as T square is equal to 4 pi square L upon G, where T is our time period, L is the effective length, and G is our acceleration due to gravity. So, for a given length of pendulum, the acceleration due to gravity at a certain place is constant. That's why at that place time period is also constant. So that is the reason why a pendulum can be used to measure time. Okay, students, the pendulum of a clock that we generally use at home is nothing but a seconds pendulum, and it takes 1 second to travel from extreme to extreme. Okay, that is why the time period is 2 seconds. That means we can say that any pendulum which has the time period of 2 seconds is called a seconds pendulum, and it has an effective length of 1 meter nearby. Okay, and the acceleration due to gravity is 9.8 meter per second square. Okay, from this we can represent seconds pendulum as a pendulum having time period of 2 seconds, effective length of 1 meter, and acceleration due to gravity which is a constant value, that is 9.8 meter per second square. Okay, students, in this class we have discussed about measurement of time. We have discussed about the simple pendulum and its mechanism. Okay, hope you have understood everything clearly. If not, please watch the video again, go through the book and revise it properly, and it would help you to remember everything clearly. Okay, so as I always say, keep revising, keep practicing, and most importantly, keep smiling.